Hello, I'm Marina Bokus. Welcome to the Future of Learning. Today, along with many other aspects of our life, technology has become a common part of educational institutions around the world. Computer science is one of the top-paying college degrees with a median salary of $74,000, according to the Bureau of Labor Statistics. But it seems it goes beyond that. Just a week ago in Chicago, Mayor Emanuel announced that in 3 years' time, a student wouldn't be able to graduate from high school in the city of Chicago without taking code writing and computer science. They're making it mandatory. And Chicago is not the only example. About 25 states now allow advanced computer science to count as math or science credits. In Clarkston, we hear about coding clubs even in elementary school. What does this mean to our students? Ron Conwell and Kevin Emmons, Clarkston computer science and computer technology teachers, who are also career and technical education subject coordinators, have joined us today to share their take on computer-related education and career opportunities available to Clarkston students. Thank you so much for being here today.
Thank you, Ron.
Ron, I have a question, big question. Nowadays, everybody knows how to use a computer, even babies, maybe especially babies. And it's getting easier as we talk. But yet, coding becomes a popular word. We hear a lot about it. And coming directly from computer science, it seems sort of an abstract concept. Could you shed some light on what coding is all about?
Sure. I think the common misconception is that coding is something that was developed by a computer, and that we as humans have to assimilate this new piece of information in order to be able to handle it. But the reality is that coding is a human experience. We as humans created coding so that we could communicate our purposes to computers. So every day, all of us get up and we program for ourselves how to successfully navigate a day. We do problem solving, we create steps to solve those problems. We in effect are programmers of our human selves. All we try to teach in computer science is how can we take those specific problem-solving skills that we have and then transfer it to a language that we can make a computer understand, and then try to make that computer do tasks for us.
Okay, well, talking about language, going back to Chicago and Major Emanuel's statement, he actually said that code writing is the language of the future. And to me, it's quite an interesting statement because it seems that programming itself can be done in a number of computer languages. So how could code writing be really the language of the future?
Well, I think he's on point. The reality is that programming as a language is very similar to communications as humans. We talk to each other in different languages, but we still communicate. So if we're communicating with a computer on how to solve a problem, sometimes some problems can be better solved with one computer language, and then in other instances another computer language would be more appropriate. We at Clarkston would like all of our students to have more than one language skill in computer programming before they leave. So we teach both Visual Basic Programming, which is one language, and then Java programming, which is the AP computer science language. Once you understand the tools of how to solve problems, the syntax of the language is easily adoptable from one language to another.
Okay, and generally, do you think that what he's referring to is that the technology would be so prominent in the future that you need to know that, or is it allow people from different side of the world to communicate if they know the programming language?
Right, the idea that we can solve a problem and then I take that solution because it's written in a computer programming language and then solve that problem, giving that solution to other people across the world,
okay,
that's where we get into the idea that it is the world's language.
Okay.
Because in the end, if I solve a problem here that utilizes computers as a platform, there's no reason that that solution couldn't be implemented, even with slight changes to it, in other cultures around the world.
Okay, that's very interesting. Well, Kevin, you are more of a technology person. So to me, the difference between you and Ron would be that he is more of a science, computer science person who is dealing more with the creation and programming, and you're dealing more with the application of it.
Correct.
And obviously not every Clarkson graduate is going to be the programmer. And many parents might ask, why would my child need to know how to program a computer? And most importantly, how can they be applied to something else?
When I was looking at some of the more recent labor statistics, I found that in Michigan alone, there are currently 15,000 jobs available that need some sort of coding background. Not a computer scientist per se, but to have some programming background. 2/3 of those jobs are not in computer science at all. So the majority of the jobs are in manufacturing, they're in healthcare, they're in government, not something that you would expect to be a computer programmer per se, but still needing to have that computer science background.
So how could you use that in engineering, let's say?
Most of what we do with engineering is taking numerical information and then making a prediction about something. Using that prediction to then test it and see if we can make it work before we get it out to the public. And so from an engineering standpoint, we're using coding behind the scenes, but still having the fundamentals. You know, Rana mentioned that it brings in problem solving.
Yes.
We need that problem solving skill, and coding can be one of that first steps to getting the students to think, to solve challenges in a simulation environment where we have no effect on the real world, and so there is no real bad outcomes per se. But not only that, when they're working on this environment, even with a coding standpoint, they have to work as a team. Because even within big corporations, there's a team of individuals that is analyzing the problem, and there's a team of individuals that is then testing or debugging that problem before it even gets outside of their realm to the beta testers, and even still that requires some communication and collaboration.
Yes.
So basically, when you're talking about coding, what do students do? They have to create steps and specific numbers so the computer can do something?
What we usually try to teach them with is first come up with a plan.
Okay.
And from a coding standpoint, we call that writing pseudocode.
Okay.
From engineering standpoint, we call it writing your design brief. And from an English standpoint, we call it writing your rough draft, or maybe making your outline.
Okay.
So we need to understand what that problem is. We need to understand who's going to be using this. We're going to have to understand what environment are they going to be in. And we have to know all the kinds of inputs and outputs. Before we even tackle anything, we have to know all of our knowns and unknowns. From there, we make a step-by-step procedural plan of what am I going to need to make this do its job? Do I need to have some variables? Do I need to have some sort of sensors? What are these tangible things that I need to have? Is it going to be keystrokes or mouse clicks? And then from there, we make the algorithm. What is the step-by-step procedure? You know, when you're cooking in a recipe, you need to know all your ingredients and how much and what temperatures and what times. But then you also have to have that step-by-step if you want your souffle to not fall.
Absolutely. So then, just apart from the application, you just mentioned that students will also develop some essential skills that are going to be valuable to them no matter whether they go in that particular field or not. So what are those core skills that they're going to develop?
Number one, of course, problem solving. Number two is the collaboration. I talked about those already. But underlying all of that is a sense of digital literacy. By understanding the coding and understanding the language of computers and technologies, our students are going to become digitally literate with their environment. And as you know, we're all attached to our digital devices. That is going to be critical. But by doing so, it can be a stepping stone to becoming full literate. And I know a lot of our ELA teachers are working with digital tools that students can be more comfortable with, especially students that are non-traditional learners or students that are challenge learners. They can then use that as a bridge.
So problem solving and also communication?
Absolutely.
Yes.
All right. But if the student does decide to go in computer science, I also looked at some labor statistics, and I believe it's only 2.5% of all graduates who do get degrees in computer science. And that seems to be a very good job to have, and it's also something that is in high demand. So what can we do, perhaps in Clarkston or generally in education, to steer more people, more students into that area?
The university professors realize this, and the industry people have realized this, that we need to start them as young as possible. Because students are not going to go to a college where they're paying tuition to look at computer science if they have absolutely no experience. If all they've done is been a user, a passive user, but not a proactive thinker and designer, then they're not going to make it that big jump. So we've done a very good step at Clarkston with our high school program. We're one of the highest enrollment rates within our county of computer science at our high school program. But it's a part of going younger and younger. So we brought our computer science classroom back to the junior high, and we started last year a national program called Hour of Code, where we're asking teachers and students and even parents at home to spend 60 minutes, 1 hour of the year, trying to learn to code in something you have never done before. And with the advent of Web 2.0 technologies, you can go to things like Khan Academy, Code Academy. There's all kinds of web tutorials to learn. Maybe you want to learn how to write a website. Maybe you want to learn something called Scratch, which is a very unique, interactive, clickable kind of programming environment. Spend 60 minutes. That we started last year. The students are thriving. Lots of small coding clubs, you had mentioned coding clubs,
Yes.
are starting at our elementaries.
That's what I was going to ask, because it seems that elementaries start doing it
Yes.
as well. It's most like an introduction. So let me rephrase it. In order for somebody to be interested in this career path, they need to know what it is first and get an interest in it.
We need to show them what it's like, and that it's that, you know, I read a quote, Steve Jobs said, it's really important to realize that everything around us has been designed and created and implemented by somebody who is no smarter than you are. So if you realize that you are just as capable as everybody else who's designed everything we've ever experienced, that's very powerful.
It's very powerful, indeed.
It's part of why I said that we want to make sure that the students understand it's a human context.
Human.
Programming is not computer related, it's human related.
Well, computer is a machine,
Right.
so a machine can think.
And we have to do the thinking for it. So when we write code, we're just writing thinking for the computer to emulate.
A lot of the jobs that people are saying that we're losing are in the manufacturing realm. They're being replaced by machines, being replaced by computers. But it takes a human to design it, it takes a human to program it, it takes a human to fix it, it takes a human to reprogram that if it's not doing its job. It takes a human to then do the customer service to support and train the individual to use it. That's a tremendous amount
So
of jobs.
that's where the jobs.
There are the jobs.
And that's why you see the numbers.
You're replacing one individual or maybe a team of individuals, but then therefore you need so many more humans to support that technology.
Just a different type of job.
Exactly.
Instead of manual, it's more of a thinking.
Mhm.
So the mission of our schools is to cultivate thinkers and learners and productive contributors to our society. So what does your department do to fulfill this mission? And I also know we have other career opportunities for students as well. Could you share some on that?
Yeah, the areas that we have career pathways are, first of all, in the information technology, we do computer programming, but we also do hardware repair and networking, which is just getting the computers up and running, building the computer. Many students really enjoy the idea that they can make their own. And then networking the computers, getting them to communicate with each other. And we know in our current context, if a computer does not talk with another computer, we can't share information, we're probably not interested in having that device. So that's a very important area that students might be interested in taking. We also have web design, which is that ability to share information across the World Wide Web, and many students enjoy that. But outside of the computing area, we also have engineering, and we have general education, training students to become teachers. We have marketing. Even in this world, computers, we don't get them out to individuals unless we're able to market them. We also have accounting. I think the fundamental understanding of how money works is a critical skill that every student needs before they leave, and that accounting class takes care of those. And we have
a business pathway.
right, business administration management. That is another career pathway that we have that allows students to understand the leadership component of how a business should be run, and in the context of our current computing environment. How do I share information securely? How do I make sure the right information gets to the right people? How do I make business decisions with the right information? So all of this is the things that students will have available to them in the career pathways that we currently teach.
And the last one that we do at the high school specifically, that's not so much the younger ages, is our media program, producing programs like your show.
Right, that's true, yes.
That's why we have so many students here all the time, perhaps?
Yeah,
Now
well,
that's a
wonderful
pathway that
experience.
we have. It's not a career tech pathway, but it is a pathway that we have, along with all the core courses that are offered.
So the students can just take individual classes, or they need to take a number of classes in order to go into the specific path?
We believe in career exploration. The last thing we want is for a student to leave high school not knowing that they've had the ability to explore something that they were interested in, and then going out to a situation where they're paying for courses and saying, I'm going to find out if I like this. We would like them at the high school level to take these courses and explore. If they like the idea that they're a programmer, if that's something that creates a burning desire to solve problems in their mind, we would love for them to continue in that pathway. But if they just learn the problem-solving skills and say, I'd like to direct those problem-solving skills in another area, then we more than welcome them to try another career pathway. So exploration is encouraged.
All of our pathways have an introductory type course. It's a 1 semester sort of an exploration course, or maybe a full year course. And then that way, if the students find that that is a right fit for them, we have more for them.
Okay, well, thank you so much. Thank you for coming. Thank you for your time. It seems obvious that the ways the schools are using technology have changed considerably over the last few decades. This reflects a fundamental shift in the way educators think about computers. The computer's true power as an educational medium lies in their ability to facilitate and extend children's natural drive to construct, explore, experiment, evaluate, draw conclusions, in short, to learn all by themselves. And whether our children make progress in their career or not, a persistent, analytically thinking problem solver with good communication skills is in high demand in every business and truly in every area of our life.